controlling access via authorization. Let's jump in. The question we're focusing on in this video is once Bob has successfully authenticated, which is what we covered in the previous video, now how do we control what he gets access to? And there's lots of different ideas and methods depending on our situation that we can use regarding granting authorization or access to various resources. One general rule, that's a good one by the way, in any secure environment is the rule of least privilege, which basically says Bob or Lois or anybody else who is an authorized user in the system should only have enough privileges and rights to do what they need to do for their job and no more. So the rule of least privilege applies to user access to resources. It also applies to rules that we might put on firewalls, where a firewall just may say no to virtually everything except for specific traffic that has been indicated in an access control list that is allowed. Again, only allowing those protocols that are needed. Maybe on the DMZ we have a web server, and so maybe the firewall is only allowing from the outside coming in initiated connections if they're coming into the well-known port of 80 or 443 if we're using SSL to the IP address that represents that specific server. Or if we're doing clustering, maybe that group of servers. So for the rule of least privilege, just enough regarding rights and privileges, and no more than what's needed. Another thing to consider when we're handing out rights and privileges is the separation of duties. Now, that's not a new concept to us. We've had a previous video discussion about separation of duties, and the concept is this. If we want to make sure that the network is secure, the systems are secure, we don't want to have a single individual who can topple the entire apple cart. For example, if we have Kevin, who is our programmer / developer, and he's writing the code and the updates and so forth for our custom applications, we would want to make sure we have a different person, maybe Mike, who is the administrator, who is actually going to implement those changes. And I'd like you to think back to why we would want to separate those duties and not have, for example, Kevin write the code and implement the code. What are the reasons why that might be a bad idea? Now, if you're saying, Keith, the reason we wouldn't want Kevin to write the code and implement the code is because we have no checks and balances. He may have some malicious software, he's now implementing it on our production network, and we don't have controls in place to check for that. And that would be absolutely correct. So Mike, as an administrator, would go through change control, and there also might be some additional steps of verifying the security posture of that update or that new software before we're allowed to go ahead and roll it out into our production network. Another great example of separation of duties is an individual who would request a purchase order to buy something and a different person who approves the purchase order. So this would be person 1 and this would be person 2. And again, the benefit for us as an organization is that we don't have a single person with too much authority or permissions or rights, which potentially might be abused by that single individual. Now, one of the challenges with separation of duties is, let's say we have a new person, let's say John comes on board, and John's going to be responsible for purchase requisitions. And let's also imagine that Mary comes on board, and she's going to be responsible for approving purchase orders. Well, the tricky part about that is, if John comes on board, and then we have to go to John's account and say, okay, to do the purchase recs, John needs this and that and the other. It might be an administrative burden for every individual to give that one user all the exact rights they need for their specific job functions. And the same thing with Mary. So to help ease the burden, the administrative burden, of giving John and Mary the specific rights they need and all the little details, what we can do is we can use role-based access control. And a prime example of this is groups. And I'll put this in blue. Maybe we make a purchase rec group, and the group is given all the detailed rights that they need for the purchase rec process. And we make another group, maybe we call it purchase order approvers, and we give that group all the exact details and rights they need for that specific function. And then here's the exciting part. All we need to do when John comes on board is make John a member of the group, and John will automatically inherit all those specific rights he needs for that job function. So if John's role is doing purchase recs, if we put him into the appropriate group, he'll automatically have all the rights he needs for his specific role. And the same thing for Mary. Mary comes on board, we create her user account, and we make Mary a member of the group called Purchase Order Approvers, or whatever we called that group, and she would inherit all those specific rights regarding that job function. So the groups have rights based on various roles, and we simply put users in those roles. Now, to keep on top of this, we'd want to do a periodic review of our users and their rights and what groups they belong to. And we'd also want to make sure in this example that we don't put John into group 1 and to group 2 at the same time. Otherwise, if John is a member of group 1 and he has all the rights to do a purchase rec, and he's also a member of group 2 at the same time, where he can approve purchase orders, that defeats the purpose of separation of duties. Because we want those controls in place. And the concept of doing separation of duties is a management control or an administrative control, and the actual enforcement of what John is allowed to do or what Mary is allowed to do based on their group membership, those are implemented via technical controls that prevent them from doing things outside of what they're allowed to do. For example, if John's a member of this group right here that can request purchase orders, but he's not a member of the group that can approve those purchase orders, those technical controls in place are going to stop John, because he doesn't have the rights and permissions, to go ahead and approve his own purchase orders. So this role-based access control using groups is pretty much focused on job function. What that individual at the organization, what's their job, what rights do they need? They're made a member of the group that has those associated rights, and we're mostly done. Now, when I say mostly done, there are going to be some odds and ends that we might have to specifically do for a user. For example, let's say that Mary is a member of this group that has the ability to approve purchase orders. And in addition, she needs some specific right over on some remote system as well. Even though we're doing role-based access control via group membership, we can also specifically associate certain rights and privileges as attributes associated with Mary's account. So she would have all the rights of the group, plus whatever specific attributes or rights that we gave her or her user object inside the system. And an example of that might be the rights to her home directory, which would be specific just to her. And when possible, we want to do group management and role-based access control to help ease the burden of individually managing the rights of every single user at a detailed level. ACL is an acronym for Access Control List, and a literal access control list can exist on firewalls and routers to specifically identify what traffic is allowed, but we can also use the idea of access control list on systems and files and directories. For example, if Bob wants to access file X on this system, based on the technical controls in place on that server, the access control mechanism may say, yes, Bob, you're allowed to have access to this file. Or maybe it's just read access, or write access, or maybe it's full access, depending on the access control set up on that server. As you can imagine, in many networks, the data that's being stored is very sensitive. And for many governments, the data that they carry and store is highly sensitive and highly confidential. So one of the methods that we can use in an environment where we need strict controls on who can see what type of data, we can use something called mandatory access control. And the acronym for that is MAC. Now, the actual acronym for MAC, we use that lots of places. For example, a MAC address on an Ethernet adapter, which stands for Media Access Control, or MAC, like Macintosh. But in the case of authorization and access control, we're going to realize that MAC refers to Mandatory Access Control. And that effectively means it's not optional. Here's how mandatory access control works. We're going to have a centralized control method for the whole system. So let's say, for example, this is our whole system right here. And in a mandatory access control environment, we may or may not be connected to other networks because of security reasons. So I'm going to go ahead and take off the internet just for this discussion. And here's what we're going to do with mandatory access control. We are going to label all of the data that comes into our system with a classification label regarding that data. As an example, we might have top secret. So some data comes in, and we label that data as top secret. When I say we, I'm talking about the organization that's in charge of this system. Other data that isn't quite that sensitive may be labeled secret. And there may be some data that's considered to be unclassified. And there are more labels than just these three. But the concept is, any data that comes into our system, we are going to label it with a sensitivity label or a classification label. So now let me share with you how that really makes a difference. Now that we have all the data that's labeled with sensitivity labels, we take users like General Bob, or Commander Bob, or whatever his title is, and Bob is going to be given a clearance level. So let's say, for example, that Bob, the actual user object, Bob, has been given a clearance level of secret. And now, as Bob tries to access data and access resources on the system, Bob will be able to only access up to level secret and possibly below. depending on the exact implementation of this mandatory access control system. The key here is that Bob, because his clearance level is at secret, he would not, I repeat, he would not be able to access top secret information. The other thing about a mandatory access control system that's important to know is that just because Bob has a clearance level of secret doesn't mean that he can automatically waltz through the entire system and see all of the secret information. There's also compartmentalization and also something called need to know. So let's imagine there's some data that's labeled as secret, and maybe it's regarding greenhouse effects or something else. So this is the data that Bob would like to access. Now, in order for Bob, or anyone else, by the way, to go ahead and access and get access to this data, which has been labeled as secret regarding its sensitivity label, Bob would need to have at least that clearance level, which he does, and he would also have to have this magical thing called need to know. Otherwise, he would not have access to this data. And that's a good thing, because he wouldn't want to have a single individual with, for example, top secret clearance who could just wander through all the data anywhere in the system that's labeled top secret and have full access to it. Compartmentalization is a good thing to help protect secrets. The centralized control would be managed by the security team for that organization to make sure all data that comes in is properly labeled, and also to make sure that users that come in are given the correct clearance levels. And mandatory access control is the toughest and most stringent method for managing access to data. And that brings up another point. Well, Keith, what are some other methods for managing access to data besides doing mandatory access control? Well, we could do role-based access control. And with role-based access control, which we just talked about a moment ago, we've got a user like Bob, and Bob is made a member of a group, and that group has rights or permissions or privileges. And as a result, Bob inherits the rights and privileges of that group. The key here with role-based access control is that there's no labels involved, there's no clearance or privilege levels involved. It's a little bit more lax. Whatever Bob is given rights to, he can go ahead and access. So the administration team in role-based access control would want to make sure we're doing periodic rights reviews, making sure we know exactly what Bob does have rights to, and make corrections as needed. In the event we have privilege escalation or privilege creep, where Bob has unintentionally more rights than he really needs in the system. Because if Bob does have more rights than he needs in the system for his job, we wouldn't be following the rule of least privilege. And if Bob has too many rights, Bob could then potentially make changes that he shouldn't, seed data that he shouldn't, or otherwise compromise our security of our system. And as a result, there would be more risk to our system because of the excessive rights that Bob has, as a potential for him to use those rights in an inappropriate manner. Another type of access control model is called the discretionary access control right here, and that is DAC. And here's how discretionary access control works. Let's say we have Bob and Lois, and let's say we have a few other users. They may be wireless, or they may be connected to the switch with a Ethernet cable. So we have Jim, Kurt, Sean, and a whole bunch of other really great people. So with discretionary access control, Lois decides, hey, you know what? I've got some files on my laptop. I'm going to go ahead and share them. And because Lois is the owner of that data, she can decide what she wants to do with it. She shares it on her own. And maybe Jim has some data and he shares it. And maybe Kurt has some data and Kurt shares it. And maybe Bob says, wow, great, there's data on Lois's system and Jim's and Kurt's. And the reason it's called discretionary access control is because it's at the discretion of the person who owns the data regarding how they want to control it. So if Sean over here says, you know what, I've got some data, but I'm not going to share it with anybody, hey, it's up to him to decide. It's his discretion whether or not he wants to share that data. So discretionary access control is really the weakest or loosest method of access control that's on this list. Now, in a corporation, it's not likely that we're going to allow peer-to-peer sharing from individual workstations, but we might have some managers. And maybe a manager is in charge of the data that sits on server number 1. And in this example, this manager who owns that data would have the ability to identify who should get rights to it. For example, what users and or groups should have rights to that data or to those applications on that system that this manager owns. And that would be an example of discretionary access control. It's at the discretion of the manager to decide who is going to get access to that data. So if you and I were going to make a list of access control methods, starting with the highest level of control, the highest level of control would be mandatory access control. Below that, we'd have role-based access control. So with Mac, we have a security team managing everything. With role-based access control, we have an administrator team for the company and the organization. creating groups, putting users in those groups. And the loosest method is the discretionary access control, where individual managers and owners of that data are simply making decisions on who should get access to that data. Now, just to make it fun, there is another acronym, RBAC, right here, which is rule-based access control, not to be confused with role-based, which is like our groups example. And rule-based access control is simply a method of implementing the technical controls. For example, on a firewall, we might have some specific rules as far as what is allowed through that firewall and what is denied through that firewall. Or on a server, we might have a set of rules regarding which users are allowed to run which applications. So although this also has an acronym of RBAC, the rule-based access control is simply a method of implementing the technical controls to either permit or restrict access either on the network or on a system. Now, from a certification perspective, if somebody just showed up and said RBAC, and they didn't say if it's rule-based or role-based, I would go ahead and assume, this is me personally, I would assume they're talking about role-based access control, especially if it's in the context of access control methods, like mandatory access control, role-based access control, or discretionary access control. If it was in the context of what methodology might we use to implement the restrictions on a firewall, in that context, it's very likely going to be rule-based access control implemented on either a router or a firewall. And then when we're implementing our controls, whether it's an access control list on a firewall or on a router, or it's an access control mechanism on a server for an application or files, in most systems, we're going to have a default behavior of an implicit deny, which basically says if you weren't invited to the party, if you weren't specifically allowed, I'm sorry, no access is going to be given here. And if we have systems that don't have that kind of an attitude of an implicit deny, we should invoke that with an explicit deny. For example, on a router, if it didn't have the default attitude at the end of an access control list to drop everything that wasn't specifically permitted in that list, we could add a literal line at the very end of the access control list saying, deny everything. And of course, you and I would implement that in the correct syntax for that vendor, whether it's Juniper or Checkpoint or Cisco or HP, using the correct command set for that vendor's specific equipment. One other aspect that we could tie to most of this as well is time of day restrictions. For example, if Bob is trying to get access to some resource, a file, an application, some service, it could be time-based, the actual implementation of the controls. Maybe Bob's allowed to have access to that data if it's between the hours of 8 and 5 p.m. on weekdays. And any time outside of that, Bob is not allowed to have access. Another example is if Bob wants to go out to the internet for personal reasons. Maybe he wants to go to online banking or gaming websites or whatever it is. We can set up access control lists that are tied to time of day so that we can allow certain protocols during certain times of the day. For example, maybe Bob's lunch hour or a break, where during that time certain protocols and traffic is allowed, or certain applications or files are available during that window. And we can also use time of day restrictions for general network access altogether. Perhaps Bob can only log on to this local computer during certain times of the day. And we can implement those restrictions with access control mechanisms. And those would be examples of technical controls that are restricting Bob from being able to log in or access resources during certain times of the day. I've had a great time, and I'm glad you joined me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.